Good evening, everyone. As in the last class, we had discussed some very good problems on the concept of relative velocity. And in continuation of that, let us start with problem number 4. There are two particles, say the particle A and the particle B. Particle A is moving with constant speed small v and is continually aimed at the particle B. And in turns, the particle B starts moving with constant speed u in the horizontal direction. At t is equal to 0, their separation is small l and velocity of the particle A is perpendicular to the velocity of the particle B, and also speed of the particle A is greater than the speed of the particle B. And we have to find the time of convergence, that is, after what time they will meet. So, the path of the particle A looks like so look at here. Both the particle will meet there. Then it takes some time and we have to find this time. However, this time is known as the time of convergence. So, during the motion, say at time t before the converging time arrived here, then its line of motion, look at here, the line of motion of particle A, say, makes an angle of alpha from the horizontal. Just we are going to use the concept of relative velocity. Velocity of particle A with respect to the particle B. Velocity of particle A plus of minus velocity of particle B. But we are interested its component in the direction of line of motion of A at time t, that is in the aimed direction. VAB aimed is equal to VA aimed plus of minus VB emmed so this is equal to here speed is constant, so this is V plus of minus, so here is say U speed in the horizontal direction is constant, so its component in the emmed direction is here U cos alpha V minus U cos alpha. However, this speed V minus U cos alpha is variable. Why? Because alpha changes as time goes on, means alpha is a function of time, so definitely it is a variable. But we are interested in dt time, infinitesimally small time, then we may take this speed as a constant. So the distance covered in the emmed direction in this dt time, so this is, look here, V minus U cos alpha into dt. Integrate it from t is equal to 0 to t is equal to t naught, where t naught is the converging time. So this comes out to be, look at here, at t is equal to 0, their relative separation is L in the emmed direction, look at here, in the emmed direction. And when they will converge, then in the emmed direction relative separation became 0. So this is equal to L. Now take it as a 1. So here alpha is a function of time. So one cannot evaluate this integral because the integrand is the function of time, but in which way it is not very clear. So integration of this is not possible. Then we have to look for the alternative approach to find that. So what is the alternative approach? Look at here. Say at time t is equal to t0, the distance covered by the particle b, so speed is constant, then we may apply dvt, distance is equal to speed into time. So look at here, this is u into t naught, this must be equal to, look at here, say this is the position at time t, this is the position at time t, so v cos alpha in the horizontal direction, because in the horizontal direction both the particle b and as well particle a cover the same distance for the convergence. It need not be, but my problem is that they will converge. It is possible only when the horizontal distance covered by both the particle must be same, otherwise they will not converge. So this is v cos alpha into dt. But again this is not constant, but for this time dt we have to assume it is a constant. So now integrate it from 0 to convergence time t0. So from here 0 to t0 cos alpha dt, this is equal to u t0 over v. This is taken as equation number 2. Now from equation number 1, because by the property of integration we may break it into two integrals. The way, look at here, 0 to t v dt minus take u, which is constant, out of the integrand, here 0 to t0 cos alpha dt. This is equal to L. Now from 2, it comes out to be v into say t0, v into t0 minus u. This integral is replaced by equation number 2. So this is u t0 over v, and this is equal to L. Now this implies t0 is equal to v into L over v square minus u square, because it is positive, because v is greater than u as in the problem. So our task is over and we succeed to find the time of convergence. This is the problem. Now look at the problem number 5. So here there is a large, you may call it very long cabin. Say length of this cabin L is equal to 24 meter. Very unusual. Just we have constructed the problem. This cabin has a bolt attached to the ceiling, and this is the floor. The ceiling to floor distance is 24 meter, and this cabin slides along the shaft, which is firmly attached to the ground. Shaft. At t is equal to 0, this cabin starts moving upward with acceleration of magnitude a naught is equal to 2 meter per second square with 0 speed, say v0 is equal to 0, and after t is equal to, say t is equal to 2.5 second, at t is equal to 2.5 second, the ball detached from the ceiling. Then we have to find the ball's free fall time and the magnitude of displacement and the distance covered by the ball with respect to shaft, or you may call with respect to ground, supposed to be stationary. So what is the question? Question number 1, find bolt free fall time. And problem number 2, the magnitude of displacement and distance of the bolt with respect to shaft, that is with respect to ground. This is the problem. Now just we are going to solve it. Look at how. Firstly, we want to find the speed of the cabin along with the bolt. Supposed to be the bolt is not detached. For this, we take here origin, upward direction, positive, say y-axis, and we work with respect to ground or with respect to ground observer. So here Vy is equal to V naught y plus Ay into t. So Vy we have to find V0 y, start with 0 speed. Look at here, V0 is equal to 0 plus Ay, say A naught there, into t. T is already given there, say it is better to take T naught. T naught is here, put it, A naught 2 meter per second square and T naught is 2.5 second. So it comes out to be 5 meter per second. Obviously, during this time, the cabin and as well the bolt has moved some distance upward. Look at here. Suppose this is the situation of the cabin along with the bolt after time T naught is equal to 2.5 second. Look at here. Now at the same time the bolt is detached and we have to find free fall time firstly. So we may find free fall time with respect to ground frame as well with respect to elevator frame, as the article, the concept of relative velocity. So we are going to find the bolt free fall time with respect to cabin. Suppose here the observer. Now for this we have to use the relative concept. Velocity of the bolt with respect to cabin, velocity of bolt with respect to ground plus velocity of cabin with respect to ground with minus sign, because we have to nullify the effect of velocity of cabin and then add it to the velocity of the bolt. So look at here, at t is equal to t0, say 2.5 second. We may think just before detachment, then both the cabin and the bolt has same velocity in the upward direction. So look at here. So this comes out to be 0. Now suppose here is uniform gravitational field pointing vertically down, say G. Now we are interested here, acceleration of the bolt with respect to cabin. Look at here, acceleration of bolt with respect to ground frame plus of minus acceleration of cabin with respect to ground frame. So look at here. So again, these two are with respect to ground frame, and we have to find the acceleration of the bolt with respect to cabin. So here, supposed to be origin and taken this direction, say as a y-axis. We may change the coordinate system as per our requirement. That is why. So here a b c y, a b y plus of minus a c y. So a b y, because it is pointing down, which is taken as a positive, and this is G, because once the ball has detached from the ceiling, then it is under gravity. So that is why it is G plus of minus ACY. Look at here. Still the cabin is moving upward. After detachment, there is no change in acceleration of the cabin. So because this direction taken as a positive, then we have to component of this acceleration in the assumed positive direction, that is vertically down. So mod A naught vector cos 180, mod A naught vector cos 180 degree. This comes out to be G plus A naught. We take here G is equal to 10 meter per second square. So it comes out to be 10 plus 2 meter per second square. That is 12 meter per second square. Now from cabin frame, so look at this, the origin is taken as a y-axis, which is positive, this direction. However, no need to mention, but if you mention, then okay, positive. So we use y motion here. Y is equal to y naught v naught y into t plus half ay t square. So y, look at here, L is the 0, v naught y. So this comes to be, look at here, 0 into t plus half ay, look at here, g plus a naught into t square. So this implies t is equal to plus minus under root twice L over g plus a naught. As we know, in my universe, time is never negative. So we have to leave minus sign and take the positive one. So t is equal to square root of twice L over g plus a naught. So this time we have to put the value twice L is 24 meter, g is calculated here 12 meter per second square. So 12 1 ja 12, 12 2 ja 24. Here 2 is taken out and the second is also as well 2 seconds. So the bolt free fall time is 2 seconds. That is, after 2 seconds, once the ball detached from the ceiling strikes to the floor. That's problem number 1 is done. As just we have calculated ball's free fall time 2 seconds. Now we have to take the second question, the magnitude of displacement and distance of bolt with respect to shaft, that is with respect to ground frame, for which what we have seen earlier, just before detachment of the bolt, the velocity of bolt as well the velocity of cabin are same. We have calculated 5 meters per second upward. Now we have to think just after detachment, as it is seen from ground frame, the velocity of bolt is in the upward direction with speed 5 meters per second. So after detachment, the bolt is under uniform gravity as we have assumed earlier. Now we have to work from ground frame or with respect to the ground observer. Look at here. For this we have to take origin here and upward direction, say y axis taken as positive. Initially the bolt has a speed upward 5 meters per second. Now the bolt's speed is 5 meters per second, which is very less than the orbital as well the escape speed. As we know, the orbital speed of any body or particle is 7.9 kilometers per second approximately, and escape speed 11.2 kilometers per second or more with respect to ground frame. Ground is supposed to be stationary. So this speed is very small, so we do not think like that. Definitely it go up and momentarily stopped somewhere in the upward direction and then comes back again at the origin, and beyond that we will think later on. So firstly starts from origin and came to origin. So with respect to ground frame, just we are going to use y motion. So here y is equal to y naught v naught y into t plus half ay t square. So again came to the origin, so final y coordinate is 0, initial is already 0, v naught y we have to put later on, this is the time we have to find, plus half ay, look at here, so g vector is vertically down and we have to take the component of this g vector in the assumed positive direction. So it came out to be mod g cos 180. The mod g cos 180 degree, cos 180 degree and t square. So here take t common, so this is v naught y plus half the minus g cos 180 degrees minus 1, and 1t is taken out common, so 1t has left here and this is equal to 0. So the first factor is t, which cannot be 0 because it takes some time to cover distances in the upward and then downward, so it is not equal to 0. But here right hand side is 0, so the second factor must be 0, otherwise this equality does not hold good. Then this implies that t is equal to twice v naught y over g. So calculate it here, this implies t is equal to twice v naught is 5 meter per second and g is already taken, see there, 10 meter per second square. So it came out to be 1 second. But Bolt's free fall time is 2 seconds. So definitely the lower end, or you may call it floor of the cabin, really below that, because bolt has to strike, bolt is to strike to the floor. So after 1 second, say the floor is somewhere here. After 1 second, bolt's free fall time is 2 seconds. Look at there. So in the next 1 second, so this floor say come somewhere here and the bolt now strike it. So it takes 1 second. What we have to find? The magnitude of displacement. As we know, displacement is a directed line segment from initial to final position. So initial is here and final is there. So this is the displacement and we have to find the magnitude of displacement. Firstly, for this we take origin here and downward direction y. We may take origin or the coordinate system anywhere as per our requirement. That is why all the times we are changing. Look at first, second and third one here. Now one thing is here I would like to mention. So when it was going up, then speed was 5 meters per second. Now under uniform gravity, when it came back at the origin, the same position, so the velocity is not same because directions has been changed, but speed remains same. So this is now for these purposes we notice 5 meters per second downward. Now firstly we find y coordinate and then the magnitude of displacement. So here y motion again, but for this condition, look at here from ground frame, and y is equal to y naught v naught y into t half ay t square. So look at here, this y we have to find, this y0 is 0 because origin is taken there. Look at plus v naught y, so downward direction is taken as a positive, so mod v naught cos 0 degree. So cos 0 degree we all know 1, so this is v naught into 1 into t. Look at here, from here to there and came back to the origin, total time taken 1 second, but time of a strike we have calculated earlier 2 seconds. So now the remaining time is 1 second. 2 minus 1 is equal to 1 second. So we have to use here 1 second. I'm not writing here unit. Finally we have to put unit as per the quantity. The half ay is mod g cos 0 this time because g is downward, positive direction taken is downward, so mod g cos 0 1 into t 1 square. So here this is 5 meters per second into 1. So we no need to put unit here because finally we have to put unit. 5 into 1 into 1 plus half, g is 10 already taken, and this is 1 square is 1. So this came out to be 10, and now finally we put unit here 10 meter. So y coordinate is positive. Therefore displacement, in fact magnitude of displacement is equal to 10 meter. Okay, so if the y coordinate came negative, then we have to put the mode, and there is the significance of mode, but here right now significance is however least, but we have to take every single steps as per the knowledge. So all the times we are targeting the knowledge. So that 10 meter. Okay. So here the first part of the second question is done. the magnitude of displacement. Now, next task is that the distance. As we all know, distance is the total path length covered during the journey. Total path length. So here to there, from there to here, and then this. We have to add up all these distances to get the final distance or the total distance. For this, look at here. So from here to there, so we have to find firstly this and then multiply by 2, because we have to add this one also, and the y is already calculated 10 meter. So we have to add up all these three and get the answer. So firstly, we use y motion in upward direction. So y is equal to, we all know, y naught, again with respect to ground frame, v naught y into t plus half ay t square. So this y we have to find, y 0 is 0 because it starts from origin. So v naught is 5 meter per second and t is, look at here, and from here to there total time is 1 second. So from here to there half second is the half plus half ay. Look at here, t is vertically down. Now this time y direction taken is upward, positive. So mod g cos 180. So this is say minus 10 and this is t and half whole square. So here 2.5, look at here, this is minus 5 by 4. So here minus 1.25. So here it is, look at here, plus 1.25. Finally we put. Now we have to write the total distance covered. Total distance covered is equal to, from here to there, and from there to here, and this much. So here 1.25 meter plus 1.25 meter total path length plus 10 meter. So this is the 12.5 meter. 12.5 meter. And we have found the solution. Look at in which way we have approached the problem. This is important. Solution is not important. The way we approach the problem, this is important. So that is why I have taken every bit of what we need. So now look towards problem number 6. Now the next problem is that there are 3 particles are present at 3 corners. Say particle 1, particle 2, particle 3. Particle 1 aimed at particle 2, particle 2 aimed at particle 3, particle 3 is aimed at particle 1. And at t equal to 0, their speeds and remain same. V speed, V speed and V speed. So if they move like that, then definitely they will converge at the center. However, path is very complicated because 1 headed 2, 2 headed 3, 3 headed 1. So path looks like somehow like that. Like that. But one remarkable thing is that all the time they are at the vertices of an equilateral triangle. That's the unique character of this motion. Suppose this is here, here and here, still we join, then give you an equilateral triangle. However, side is smaller than the previous one. So look at here, just we want to find this center, say O, say this is A, so say this corner to center distance. So we all know in case of an equilateral triangle, all the centers at one place. What? Circumcenter, incenter, centroid and orthocenter. They all are at one place, that is at the center of an equilateral triangle. So this is circumradius in fact. We all know the formula of circumradius are A into B into C over 4 into area of triangle. So here the triangle is equilateral, so that is why A is A, B is also A, C is A. 4 multiply area of triangle, we all know root 3 over 4 into side square. So look at here, side square is cancelled like that, 4 is cancelled already, this comes out to be A over root 3. So because the particles are all the time at the vertices of an equilateral triangle, so the distance covered in the direction of center. However, look at path is curved, but we are talking aiming distance towards the center. So this is the aiming distance towards the center, not the curved distance. Look at here, path is curved, that is why. So the aiming speed towards the center all the time must be same. So this is mod V cos 30, look at here, because it is in center as well, because triangle is equilateral, so this may be the bisector. So this is 30 degree. So speed in the direction of AO, this is mod V cos 30. We all know mod V is V and cos 30 degree is root 3 over 2. So this is the speed. Now the speed is constant, distance is already known here, AO, that is the circumradius. Then there is no harm to use dVt relation. So distance is equal to speed into time. Speed, so speed is V root 3 over 2 into T, we have to find T. This implies T is equal to twice this, look at there, A over root 3. 2 is taken already here, so this is 1 over root 3 into V. So look at, it comes out to be twice A over 3V. This is the time of convergence. However, we are going to solve this problem by the concept of relative velocity. Look at how. Firstly, we have to find velocity of 2 with respect to 3. So this is velocity of 2 plus or minus velocity of 3. This is velocity of 2 and this is velocity of this. It means speed is V, look at here. This is minus, say, this is V3, but mod V3 is V. this is V2. However, mod V2 is equal to V. Here minus V3. This is V2 vector. So look at vertically opposite angle 60 degree. But look at velocity V3 magnitude is equal to minus velocity V3 magnitude is equal to V, and also V2 magnitude is equal to V. So here the resultant of two vectors V2 and minus of V3, if the magnitudes are same, as we all know, resultant bisect it. So here in this direction V2 3, in this direction V2 3, look at there. So we want to find the magnitude. This is square root of, look at here, magnitude of V2 is V square, magnitude of minus V3, so this is also V square, twice V, and cosine of the angle between them, look at 60 degree. So we have to calculate it, so do it quickly. So it comes out to be root 3 into V. But look at here, in this direction distance is not given, but in this direction is given, because if we are doing like that, it means the particle 3 is stopped, because we nullify the effect of velocity of particle 3 and then add it to the velocity of the particle 2. So that is why. So we have to take the component of this V2 3 in the initial separation direction. Say initial separation is A is already the sides of an equilateral triangle. So speed along initial separation. So it is mod V2 3 cos 30 degree. Look at this angle is 30 degrees. 30 degrees. So here this is root 3 into V cos 30 degree, we all know, root 3 over 2. This it comes out to be 3V over 2. Now initial separation, this is A, and the speed in the direction of initial separation is 3V over 2. So there is no harm to use DVT relation. So now we are going to use here DVT relation. Distance is equal to speed into time when speed is constant. So here speed is 3V over 2. Time we have to find, and this D is already given A. So this implies T is equal to twice A over 3V. Look at in the first method, the time is same. Look at here. Now we have another method, but that method is very interesting, because in that particular method we are able to find the sides of an equilateral triangle at any time t, but that time must be less than this, because at this time they will converge, and beyond that time and there is no curvature at all. So look at how. However, this convergence time we may also able to find in the third method. Look at. At t is equal to 0, look at here. Particle 1, particle 2, particle 3 headed towards 2 with speed v, headed towards 3, headed towards 1 with speed v. All the times they are headed to each other. So initial separation says A side, say at any time t, but must be less than 2A over 3V. Look at here. Some later time t, side has reduced. Of course, it may be. So x of t, x of t, x of t. So now this is at time t. We have to think at time t plus dt. So this corner or the particle at that corner say came here, because this is dt times very small distance, but to see or for visibility we are assigning somehow, so that much distance. No, the distance cannot be seen by any microscope or aided or unaided eye. But to understand this, that is why I am showing like that. Came here. So now this is, so this is v dt and this is also v dt. This is say x of t plus dt and this is x of t minus v dt, and this is 60 degree because all the times they are at the vertices of an equilateral triangle. That is why. Now just we are going to use cosine rule here. Cos 60 degree v dt whole square plus x of t minus v dt whole square minus x of t plus dt whole square over twice v dt x of t minus v dt. Cos 60 degree half v dt whole square plus v dt whole square plus x of t whole square minus twice x of t v dt minus x of t plus dt whole square, because this is a minus b whole square, a square plus b square minus twice ab, like that. Over, look at here, twice v dt multiply x of t minus v dt. So to cancel from here, now this implies that x of t plus dt whole square minus x of t whole square is equal to minus thrice v x of t dt plus thrice v dt plus thrice v dt whole square. Look at here, dt is infinitesimally small, and the square of that will give you second degree of smallness. So there is no harm to neglect it. So this second term of the right hand side should be neglected without affecting to our objective. So here now this is a of t plus dt minus a of t over under root of a of t. This is equal to minus thrice v dt, where a of t is equal to x of t whole square. So this implies this is dA this is square root of a, this is minus thrice v dt. Now integrate it, say a naught to a 0 to t. Now this implies this is a to the power of minus half plus 1 is divided by minus half plus 1 plus c. So this is twice under root a c, the antiderivation constant is 0 to a, and this is equal to, look at here, minus thrice v into t. So now this implies from here, put the upper limit there. So upper limit is what? Now put in this form here. So this is x of t mod minus a mod. C is cancelled out. This is equal to minus thrice v into t. So because it is the side of a triangle, so no way it is negative, a is already positive because it is also the side of an equilateral triangle. So now remove mod. So this is x of t minus a is equal to minus thrice v into t. Now this implies that, look at here, x of t came out to be here a minus thrice v into t. So now this is the final relation. Now we are in a position to find sides of an equilateral triangle thus formed during the motion. So, but keep in mind here this relation x of t is equal to a minus thrice v into t is valid, and t is greater than or equal to 0 but is less than or equal to twice a over 3v. Beyond that time, relation does not exist. So always keep in mind that. So now just we want to find the converging time. Okay, we are able to do that because when they converge, then x of t must be 0. So this implies a minus 3v into t0. Say t0 is the convergence time. So this is equal to 0. This implies t0 is equal to, look at here, the 2 factor is missing here. So here is the 2. You may write like that here, 3 over 2, 3 over 2, 3 over 2. So this is twice a over 3v. Look at, in all 3 methods, time of convergence are same but in the same form, because sometimes we may find answer from different methods, they all are correct, but form may be different. But here fortunately their forms are also same and answer is in all the methods same. So that's the majestic of this method. But keep in mind, if the side of a vernacular triangle is known, then of course we may find the area or related anything regarding that equilateral triangle. So this method is very nice because it carries more informations. That is why, and we have taken every bit of things, every single steps. So because once you are going to watch these videos, so you may understand quite easily. Now wait for the next class. In that class we will take up Galilean transformation and velocity transformation for relativistic speeds, that is those speeds which are comparable to the speed of light. Then usual Galilean transformation or such types of relative velocity concept no longer will be valid. So we have to wait for next video with veracity.